what tends to happen is when you get to the test, you're going to have problems that are multiple parts, especially for your FRQ, which is why I'm trying to get you used to seeing, oh, this question answers this question, leads to this question, right? And even for some of your multiple choice, it may say, use this problem to answer questions, blah, 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 right? So this is a cumulative knowledge question. It says, describe the end behavior of the polynomial function, analyze the given function by stating the domain, the range, and then what can you conclude about the polynomial represented by the graph shown based on its intercepts and turning points? So you're going to identify domain, range, and behavior, and then tell me what type of polynomial do I have? Is it a third degree, fourth degree? Is it, are the points, are not the points, are the roots zeros? Are they real or are they non-real? Like what's happening with this function, okay? All right, so are we ready? So the first thing we're going to start with is the end behavior. And when we're talking about the end behavior, we're saying what's happening as x goes to positive infinity. So what's happening to our y's? My y's also go to positive infinity. What happens as x goes to negative infinity? My y's are also going towards positive infinity, right? So when I go to the left, it's forever going up. And when I go to the right, it's forever going up. We agree? Okay, because of this fact, and about to say the domain, but because of this fact, I know already what type of degree should I have? Even. We know that we're looking for an even degree. Does that make sense? Okay. Next, we're going to state the domain of the function. We're going to state it using interval notation. So interval notation, what is the domain of our function? Perfect. Negative infinity to positive infinity. We go forever to the left and forever to the right. What is the range of our function? 14. Yeah, 14 and a half, somewhere down there, right? It's a bracket because it's defined, right? It's not forever. It's not a whole. It's defined there. So it's from negative 14 and a half to positive infinity. It feels like it's because 14 is right in the middle, but it goes a little bit longer because it's counting by 4. Yeah. And this is a little bit past the middle, isn't it? It is. In my opinion. It's not smack dab in the middle at 14, though. All right. Do we feel comfortable with those two parts? In behavior, domain, and range. Doable? Okay. Now we're going to look at our intercepts. So it actually has how many real zeros? We have 2 reals. 1, 2. So we have 2 real zeros. And let's approximate at approximately x equals, it's smaller than a half. 2.3. Negative 2.3. That sounds approximately good. And then our other real is at 1.3. It doesn't matter. It's an approximation, and I think they're going to give you room for that. I say it's let's just so they can be the same ending. I'm going to put it at 1.3. So from negative 2.3 to positive 1.3. All right. So now we're there. We've estimated. So from there, we have 2 real. Now, looking at our turning points is going to help us determine, are there any non-reals? Okay. So looking at my turning points, how many turning points do I have? 3. I have a TP here, a TP here, and a TP here. Because I have turning points, that means that there has to be another, if I was on the x-axis, there has to be at least how many times do I cross the x-axis? 2, twice. If this was shifted where I could still have my turning points, right? How many more times would I potentially cross the x-axis? Twice. So that means I have 2 non-real zeros. AKA complex roots, right? Complex. Imaginary. So together, how many total zeros do I have? 4. So because there are a total of 4, 2 real, 2 non, this is a 4th degree polynomial. So it's a 4th degree polynomial with how many turning points? 3 turning points. That's how you summarize a graph. That's a full summary and analysis of your graph. Terrible or doable? So the way of knowing the non-reals is paying attention to your turning points, right? So notice how I have turning points. If these turning points could be moved or shifted, would I potentially cross the x-axis somewhere else? Yes. So there's potential for me to cross the x-axis. And another way to think about it is, how can I think about it? The way that I think about it is it's always going to be, my degree is always going to be one more than my turning point, right? So if I have 1, 2, 3 turning points, I know that my degree is 4. And if 2 are real, then the other 2 have to be complex, non-real. So I use my I go backwards than what they tell me to tell you. I go backwards. I do the turning points first to determine my degree, and then I analyze from there. So, all right, rest of the period, be productive.